Hi, class. We're going to continue our conversation on truth trees. We're going to do a few that are a little bit more complicated. So I'm going to share my screen, and we're going to look at a couple of truth tree examples that might help. All right. So if you'll remember, the last example we did in the lecture had two different letters, P and Q. Anytime you have two letters in the argument, you're going to have 4 rows going down, right? And again, you're going to insert the truth and false for the individual letters. The first column down this direction, you're just going to go, if it was 4, I'd go true, true, false, false. The next one over, you go true, false, true, false. That gives you every possible combination. When you have 3, as in P, Q, and R in this argument, so here's the argument, right? 2 premises, the line, the conclusion underneath. So we've got the argument. We now have P, Q, and R. So you're going to have 8 rows, right, that go down, not 4 because we've added a letter. And in the first row, you're going to go 4 truths and 4 false. You're just going to plug it in, right? If there's 3 letters, this is how the first one goes. The second one, you go 2 truths, 2 false, 2 true, 2 false, all the way down. Then you alternate on this third column, true, false, true, false, true, false, all the way down. Now, the reason you do it that way is it gives you every possible combination of letters so that we can look at each one to see if it's valid or invalid, right, as a whole, the argument. So again, if there's 2 letters, the first is true, true, false, false. Then you go true, false, true, false. That gives you every combination. 3 letters, 4 true, 4 false, 2 true, 2 false, then 1 true, 1 false, alternating down. So the argument is, if P then Q is premise 1, if Q then R premise 2, if P then R is the conclusion, we want to know, is this logically valid? We don't know about the truth. We just want to know, is it in the right form? Okay? So we get the letters individually. You always lay out the letters first individually. Now we've got the premises and the conclusion, right? Premise 1 is column 4. Premise 2 is column 5. And the conclusion is column 6. If at any point, if any of these rows going down has all true premises and a false conclusion, the argument is invalid, you can stop there. If that doesn't happen in any of the rows, then the argument is valid, and we know it's in the right form, okay? So we set this up, and then we look at the premises. So how do I know if something, how do I know whether I put a T or an F below column 4 here, right? How do I know? Well, if P is true, right, and Q is true, then we know that conditional must be true, because a true antecedent and a true consequent means you get a true underneath. Q and R, again, true antecedent, true conclusion, excuse me, true antecedent, true consequent. Q and R, true. What about if P then R? Well, again, we have a true antecedent, true consequent, true here. Good, we go to the next column. Excuse me, the next row. If P then Q, true, true, so that's true. If Q then R, true antecedent, false consequent. Anytime you have a true antecedent and a false consequent, we know that's going to be false. If P then R, again, true consequent, false, excuse me, true antecedent, false consequent. So it's going to be false here, right? So that's how we know what we put underneath these, right? Trues and falses. So we jump to the next one. If P then Q, true antecedent, false consequent, that's a false. If Q then R, false antecedent, automatically you know it's a true conditional. Anything can follow a false antecedent. So Q is false, false antecedent, which means true here. Then if P then R, P is true, R is true, which gives you a true underneath there. Okay? We jump to the next row. If P then Q, true antecedent, false consequent, that's going to be a false, right? What about if Q then R? Q is false, that's the antecedent, we know it's going to be true. If P then R, true antecedent, false consequent, that's always going to be false in a conditional there. All right, now we know that P is going to be false for the next 4, which gives us a false antecedent here. So these are all true. If P is false and that's the antecedent, all these are going to be true. If Q then R, Q true, R true, that's true. If P then R, P is the antecedent, we know it's automatically going to be true. So the P is the antecedent here. P is the antecedent here. So as soon as we know P is false over here, gives us a false antecedent. So we've got all trues down the row. The only question mark is if Q then R. Here, both Q and R are true. Here, Q is true, R is false. That's going to be a false there. here, false antecedent, true, false antecedent, which means true. So we've established the truth tree. Now we just have to look. Is there any point when we have true premises and a false conclusion? Again, column 4 is premise 1, column 5 is premise 2, column 6 is the conclusion. True, 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 we're safe. True, false premise, so we're still safe. False premise, we're still safe. False premise, we're still safe. True, 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 still safe. True, false, a false premise means we're still safe. True, 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 true. At no point is there all true premises and a false conclusion. Therefore, the argument is valid, right? We have a valid argument and we can move on and we know we're okay. I'm hoping that these examples are helpful to you. We'll do one more with 4 rows to ensure that we're doing all right here, right? So the letters we have here are P and Q. So we're only going to have 4 rows, right? We're going to put a column for P, a column for Q, a column for not P, a column for not Q, because they both appear, right, in here. And then the premise that we don't have is if P, then Q, okay? Here's the argument, 3 premises and a conclusion. So column 1 is a premise, P is a premise, right? Column 5 is a premise. Column 4 is a premise. Column 3 here is the conclusion. So when we assess at the end, that'll be important, right? Okay, 2 letters, P and Q. We go 2 trues, 2 false, then true, false, true, false. So every possible combination is here, right? So we've got each combination, and then we know if we've got a true P, we've got a false not P. If we've got a true Q, we've got a false not Q. True P, false not P. False Q, true not Q, right? False P, true not P. True Q, false not Q. False P, true not P. False Q, true not Q. So those are these columns here, right? These are just the inverse, the negation. What about if P then Q? Okay. Well, if P then Q, we got true antecedent, true consequent. That's going to be true. If P then Q, true P, false Q, true antecedent, false consequent. That's going to be false. A false P means false antecedent, automatically true. False antecedent, automatically true. So our truth tree is completely established here. And now we just need to see, is there any point where we have all true premises and a false conclusion? So we have a true premise P, true premise if P then Q, false premise not Q. We have a false premise, so we can go to the next row. Excuse me. True premise 1, false premise 2. We have a false premise, we can move to the next. False premise 1, we can move to the next. False premise. At no point do we have all true premises and a false conclusion, so this is a valid argument. And you can look at this complex argument here, and just by creating a truth tree, we now know it is in the right logical structure, which is very powerful. This is helping us make good arguments. It's helping us pursue truth. It's vital. Again, I hope these examples help. If you have any questions for me at all, let me know. I'd love to help if I can. And I will see you online as always. So good luck, and I'll see you soon.